and start with the session.
Okay, thank you, sir. So children, let me quickly tell you about the flow of the session. So first of all, you'll get to know your mentor, and then you'll see a short informative PPT, which will be followed by a virtual tour of dashboard of the Olympiad success, followed by a question answer round, wherein you, if you have a doubt or a query, you can put that up and get the answer then and there. And then the actual demo will begin, for which you've been waiting. Okay, I hope the flow is clear. Is it? Show me a thumbs up if it is. Okay, all right, very good. I got digital thumbs up. Okay, right. So we have with us Dr. Usha Banerjee, and she is a wonderful mentor, very experienced, and very thorough with her subject matter expertise. And I'm sure you're going to love her sessions because it is going to be a fun learning journey. Okay, so I'll not speak much. I'll request her to speak to you directly. All over to you, ma'am.
Okay, thank you so much, Monica, and good evening to all of you. I can take names only now. Trisha, Mayank, and Akshata. It's nice to see you here in the demo class today. So a little bit about myself. I'm Dr. Usha Banerjee. I'm involved with Olympiad Success for quite some years now, and I have done numerous batches. Now I've lost count of the number of batches that I've taken. And the best part is that I have students coming back to me, from class 6, 7. So they've done it with me in class 6 and then 7 and then 8 and 9 also possibly. So that I think is the best part of it. One of you wrote in the chat window that you like science, but science sometimes when it's confusing, then it becomes a problem. Okay. So my, method of teaching is to help you understand the concepts. So I always tell my students, don't learn up anything. You don't have to learn up and, just learn up blindly. You have to understand. So my job is to make you understand the concepts in such a way that you can solve all the problems which come in the various exams that you will take in the future. And what you are in the senior school now, your class 9 is senior class. So next year, all of you will be sitting for your board exams. So whatever you study today in class 9, will actually, also help you in class 10, in 11 and 12, provided you take up the science stream. So when I teach in class 9, I will focus in such a way, I'll teach in such a way that it's applicable for you till your class 12 and also further on. So my basic focus is, emphasis on is to explain the concepts so that once you understand, then everything, see, once you know things now, it becomes very easy. As long as you don't know things and if you're learning them, without understanding them, that's the problem, right? And I look forward to having you all in the class. Yeah, we have Abdul Khan also who's joined in. So good evening to Abdul also. I look forward to interacting with all of you. And the demo class today will be, all of you will be on mute, but my real classes are very, very interactive. And you're free to annotate on the whiteboard. You're free to talk, ask any questions anytime, as long as it's relevant to science, not questions out of it, right? So that's all from me, Monica.
Thank you so much, Pam. Abdul, I would request you to please switch on your camera because we do not allow students without video in the class. Thank you for coming up on the camera. So now let me share my screen for a short informative PPT. Just a moment, and I hope it is visible. Okay. So a very warm welcome to the demo and interaction program for class 9 science batch 2. As you are already aware that Olympiad Success is India's largest online preparation platform for Olympiad exams. Olympiad Success Live is India's first exclusive live classes for Olympiad's preparation. School Plus by Olympiad Success is one of its own kind of annual program that includes 8 important courses that really matter at this point of time in your life. These include mathematics, English, science, logical reasoning, communication, both spoken and written, Vedic math, and coding. Here you can get one-on-one online CBSE, ICSE, IGCSE, and IB classes for grades 2 to 12, one-on-one preparation classes for international mathematics Olympiads like SASMO, CMO, HKIMO, TIMO, Math Counts, US Common Core Math Competition, Math Kangaroo, and PRMO. So you can see our international rank holders for the year 2022-23 on the screen, and for the year 2021-22 on the screen. So classes are going to be group sessions with batch size of around 20 students delivered through Zoom by seasoned tutors. You have already met your mentor. So you get 3 sessions per week on Mondays, Fridays, and Sundays. Now on Monday and Friday, the timing would be 8 to 9:15 p.m. Whereas on Sunday, the timing would be 4 to 5:15 p.m. So there would be 5 minutes of break in between the class. So the flow would be like 35 minutes of class with 5 minutes of break, followed by again 35 minutes of session. The sessions would include a mix of theory, practice questions, doubt sessions, and discussion on previous year papers. You also get reading material and practice questions, which will be available in the dashboard of Olympiad Success. For the dashboard, you will shortly get a tour by Rajan sir. You also get free access to Olympiad Success platform so that you can practice topic-wise mock test for both science and reasoning as well as logical reasoning. Now the syllabus is available at this particular link and fees can be paid through this link. Don't worry, all the important and relevant links will be pasted in the chat box. And the fees for this course is 13,356 rupees. It is going to be a 60 sessions course. The fee includes online classes, daily reading notes and exercises, practice of previous year papers, access to Olympiad Success platform for science and logical reasoning. Now, all that you require for these classes is a laptop or a desktop with good internet speed, with camera because we do not allow students without video in the class, and headphones for better audio clarity. Now, preparation for Olympiad exams, as you are already aware, is slightly tougher than your regular school curriculum. So you need to spend some time every day so that you can cope up with the curriculum. And of course, parental support is required to monitor your progress and all. Now, in 2021-22, Olympiad Success had students from more than 3,800 schools across India and abroad, hailing from 35 plus countries. The live classes for this particular batch begins from Monday, 5th of June, 2023. I hope this PPT brings more clarity to you regarding the course. Now I would request Rajan sir to take you through a virtual tour of the dashboard. All over to you.
Sure, ma'am. Thank you for the wonderful presentation. Let me share my screen. Students, I hope my screen is visible to you. So this is actually the website of Olympiad Success. I am showing you how you can access the content. So what you need to do, you need to log in with the credentials. So once you enroll with us, we will share the credentials with you. Let me show you how you need to log in. So you need to click on my account and here you can log in with the credential. Let me show you. Just click on sign in. So this is the student profile. All the content you will find here in the live classes. Okay, what you need to do, you need to select a subject, that is Science Olympiad. Then you need to select a topic. So for each and every topic, you will find the reading material and practice question here. Let me show you how it looks like. So this is the reading material we have. Okay, this is the reading material we have. And similarly, we have practice question and answer key also here. Other than that, students, you can also schedule here, like in which session, which topic we are going to cover. Let me show you. So this is the schedule we have. Okay, so you can see like in the first session, we will discuss this topic, met in our surrounding. And in session 2, we will continue with this. And in session 3, we will have a test discussion. So after each and every chapter, there will be a test discussion. Okay. And at the end of the session, we have super classes. Let me show you. So we have the super classes. What we are going to do in the super classes? In the super classes, we will discuss all previous year Olympiad questions. Okay. Now, other than that, students, I hope my screen is visible. So other than that, students, you can access topic-wise mock test also for science as well as logical reasoning that you can access here in the worksheets. Let me show you. You just need to choose a topic. So these are all topic-wise mock tests for science. Similarly, you can access for logical reasoning also. Okay. And whenever you want, you can check your performance here. You just need to select a subject and then just click on detailed result view to check it. Okay. So this is all about the dashboard, students. Now, if anyone have any doubt or query, you can post in the chat box. Do anyone have any doubt or query, students? You can respond yes or no, or like if you have any query, you can put in the chat box. No? Okay, Akshita.
Any doubt?
Okay.
Feel free to ask.
No,
Trisha
Trisha
was
also.
trying.
Okay, let me ask some questions then. Can you tell me the days on which we're having the classes? Okay. Do anyone remember the days of the classes? Ma'am, actually, Monica ma'am shared in her presentation. Monday, Friday, Sunday. Correct. Correct, Trisha. The days are Monday, Friday, and Sunday. And what are the class timings? Eight to 9:15. Yes, correct. It is 8 to 9:15 p.m. for Monday and Friday. But for Sunday, the class timing is 4 to 5:15. Okay. Okay, students, do anyone have any doubt or query, or like shall we start with the session? Okay, I think then we can start with the session as no one have any doubt or query. So over to you, Usha ma'am.
Okay, thank you so much. So just give me a minute. I'll just share a very short presentation, though a short PPT, though I basically use the whiteboard a lot. Okay. Now, for this demo class, as I told you, all of you will be muted. But if you have any questions and doubts, please feel free to type them in the chat window. I'll try my best to answer all of the questions. In the live classes, everybody is unmuted. Okay, so that is not an issue. So so that will be very easily taken care of, right? So we start. I chose the topic of motion for a particular reason. Okay, so this topic of motion, you will have it. You will start. You are studying it in class 9 now, right? And I know that you have done it in class 6 also, and possibly class 7 also, and 8 also. It's surprising, right? You have it in class 9. You'll again do it in class 10. You'll do it in 11 and 12. So why should I study the same chapters so many times? Now, the concepts remains the same, more or less same. But what happens, the kind of problems that you do in your senior classes, starting from class 9 to 10 to 11 to 12, slowly the nature of problems will increase, right? So that is the reason I chose this topic of physics, which is motion. And motion is in the topic of physics. And I chose this topic because somebody typed in the chat window when we were asking what is your favorite subject, that I like science, but sometimes when I don't understand, I don't like it. So my job, I told you, is to help you understand it and help you like it also. So by the time you start the course with me, I want you to say that science is your favorite subject. That is my challenge. I'm using the whiteboard. Okay. So I told you that the first chapter that we'll be doing for the demo class is physics, and we are doing motion, right? So basically, the word physics comes from the word physical quantity. So physics is nothing but the study of physical quantities. So what is physical quantities? Physical quantities are quantities that you can measure. So quantities that you can measure are known as physical quantities. So what does that mean? If I tell you I am fat, you have no idea as to how fat I am, right? But I tell you, I'm 75 kilos. Then you will say, oh my God, she's fat. Isn't it? So as soon as you know the number, you can understand how fat I am. Or I tell you I am 49 years age, and then you know, oh my God, she's old and she's fat. So by giving you these numbers, you get a fair idea about the quantity. Also, say I tell you that, I'm pretty old, I'm older than you. So all of you are how much? 14, 15 years old. As soon as I say that I'm older than you, you don't know how old, right? So you are like 14 years old and I am 45 years old. So basically, a measure of the physical quantities helps us compare things. So you are 14 or 15 and I'm 49. So immediately we can compare that, okay, fine. 14 is, way almost like, more than more than four times, or, more than 3.5 times older, right? So the study of physical quantities is physics, and the quantities that we can measure are known as the physical quantities, right? There are three fundamental physical quantities, and all that we study today now, you will need it in class 10, in 11, in 12, all your life, as long as you study physics and science. Okay. And in class 9, the demarcation between physics, chemistry, and maths is very, very clear. So the three physical fundamental means basic. So the three basic physical quantities are length, mass, and time. So when you go to a shop to buy fabric for your shirt or for your dress, you go and say 2 meters cloth. So that 2 meters is the length. What is mass? Mass is the amount of matter present in an object. And time we know, because we are seeing the time now. You are seeing 8:26. So you know that, oh my God, I have to sit in this demo class for more 45 minutes, right? So we have a fair idea of time. Now, in physics, what is the meaning of object? So object can be a bat, a ball, or a human being, whatever. So we use these terms very, very often. So when we study the properties of certain, objects or bodies, we simply refer to as an object. So I am an object, you are an object. This bottle can be a body, this bottle can be an object also. Clear? Everybody is comfortable with English, right? Right? Okay. Done? So we have three fundamental quantities of length, mass, and time. So mass is the amount of matter present in an object. Most of you will tell me that mass and weight is the same, but that is absolutely not correct from the physics point of view. Weight is actually a force. So weight is a force with which the earth attracts a body towards itself. So there is a basic difference between mass and weight. Mass is, just the amount of matter present in a body, and weight is force. There is a lot of difference between the two. So henceforth, don't say that mass and weight are the same. And the formula of weight, we'll do all this in details once you come to the class, is mass into acceleration due to gravity. So acceleration due to gravity depends upon the planet in which you are in. So on Earth, the acceleration due to gravity, which we represent by small g, is 9.8 meter per second square. So the acceleration due to gravity is different for each and every planet. Achha, also, Tapasya, could you please turn on your video cameras? It is compulsory in the class to have your video cameras on. Tapasya, Sai Tapasya Mishra. Sai Tapasya Mishra, are you there? She's not answering. Anyway, we'll move forward with the demo. So, okay, in the classes, you have to turn on your video, right? Okay. Done till here? Okay, all of you know the concept of scalar and vector quantities, because that is also something which we will know, we will study a lot. Okay. In the class, in the live classes, we'll do all of this in details. Okay. So scalar and vector quantity. So scalar has only magnitude. We will use these terms very often, and therefore you have to know it. Magnitude is nothing but numerical value. And vector quantities have both magnitude, and direction. So example of scalar quantities is mass, length, time, speed. An example of vector quantities is weight. So weight of a body always acts downwards. Then we have velocity, force, acceleration, so on and so forth. So for all of these, vector quantities, direction plays a very important role. Done? Okay, Sai Tapasya, okay, fine. She's at the dentist, not an issue. Okay. Done? If you have doubts, questions, you want me to go slow, you want me to stop, just, type it in the chat window. I'll definitely see your messages. So difference between scalar and vector. So whenever we study any physical quantity, we will first study what is the physical quantity. Second, we'll study the formula of it. Third, we will study whether it's a scalar or a vector. And fourth, we will study what is its unit. So suppose I tell you I went to the market and I bought 20 apples. So you know that I bought 20 apples. And I say that I bought 20 kg of apples. So this kg or kilogram is a unit. So in physics, not even physics, in science, physics, chemistry, mathematics, unit of measurement plays a very, very important role. I tell you I am 49, okay? So you don't know whether I'm 49 kilos or 49 years or what, 49 apples or 49 cats or 49 dogs. So the unit of measurement plays a very important part in science and mathematics. If you all of you I know are preparing for your board exams, all of you are which board? If you can type it in the chat window. All of you CBSC, anybody from ICSC or IGCSC or any other board? Okay. All CBSC, Tapasya CBSC, CBSC, Trisha CBSC, others? CBSC, everybody CBSC, yeah. So in the board exams, if you write a numerical or you solve a question without the unit, you will have your marks deducted. So the unit of measurement becomes very, very important. So the next thing that we will do is we will study about the systems of units. So essentially, we have three systems. One is the international system of unit, which is known as the SI system. Second, we have this is also known as the MKS system. Second, we have the CGS system of units. And third, we have the FPS system. I will tell you one by one what is it. So in all, I told you the three fundamental physical quantities are length and mass. Achha, let me write mass first. Achha, let me write length only first. Wait. So length. Then I have got mass. Very easy to remember. You don't have to learn up anything. I told now, you don't have to learn up anything. You simply have to understand. So these are my three, physical quantities, fundamental physical quantities. In the SI system, length is measured in meter and meter is M. Mass is measured in kilogram. Kilogram is kg. Time is measured in seconds, S. So understood why MKS, M for meter, K for kilogram, S for second. So this is where the MKS comes from. So very, very simple to remember. In the CGS system, length is centimeter. So cm, mass is grams. and time is second. So that is the reason CGSE for centimeter, gram, and second. And in the FPS system, length is foot, mass is pound, LB is the short form for pound, and time is second. So F, P, and S. So easy to remember. Done? Understood? Now, all of you know that the currency in India, we use Indian rupees, right? INR, we write INR. So tomorrow, if I take you for a holiday to the USA, okay, America, so will Indian rupees work? No. You have to buy what is called US dollars, right? If I take you to Europe, you have to buy euro. So this is such a big headache now. If you have to travel across various countries, you need that currency which will work in each and every country. So it's a real headache. We did not want the same problem in science. So that is the reason it was decided that in science, we will all use the SI system or the international system of units. So today you're studying, all of you are from India, right? Anybody from outside India? Normally we have a lot of students from outside India. So today you're studying in India. After your class 12, you possibly might go abroad to US or UK or wherever it is. Wherever you go, the SI unit of length is meter, the SI unit of mass is kilogram, and the SI unit or the international unit of time is seconds. So with respect to science, this standardization of unit makes our life really easy. Now, can you tell me one place where even, ma'am, I'm from India, but I live in Oman. Okay, Abdul, okay. So what is the currency in Oman? Dirhams. Abdul, type it in the chat window. Omani Riyals. Okay, okay. And how much? Omani Riyals. Okay, fine. Okay, now, can you tell me one place where we still use pound? FPS system is basically an old system. Okay, 214 rupees. Okay. So we normally use, pound in one place. FPS system is the older system of units, right? Nowadays, it's very, very, very less used. But in one place, we still use pound a lot. When you have a birthday party, you get a cake, right? So we say get a 1 pound cake or a 2 pound cake or a 5 pound cake. So this pound system of unit is still used in bakeries. So this is actually the British system, which was used in India when the British ruled over India. But in India, as of now, all across the world also, yeah, Akshata, right. In US, they measure meat in pounds. They also measure a number of things in pounds, even in the US and in the UK. But yeah, from the science point of view, we will be using the SI system. Okay, clear? So whenever we do a particular, parameter, we will be studying what is it, what is the formula of it, and then what is whether it's a scalar or a vector, and what is the SI unit and what is the CGS unit. Now, this topic is motion, right? I'm sitting on a chair. Now it is 8:38 in my clock, in my, I use an iPad, so the clock is 8:38. At 8:38, I'm sitting on this chair. I will remain on this chair until I get up and move, or until one of you comes and pushes me out. So basically, motion is nothing but the change in position with respect to time. So whenever we are talking about motion, the factor of time plays a very important role. At 8:39, I'm sitting here, go to the kitchen or go to the washroom or whatever it is, right? So motion depends upon time. One more thing, suppose you're in a bus or in a train. So to describe motion, we need a reference point or an origin. Okay, so why? So people sitting inside the bus or the train, with respect to all the other passengers inside the bus, they are at rest. But to somebody standing outside the bus, you are in motion. So in physics, the concept of motion is always described with respect to time and also with respect to a reference frame. So suppose me and you tomorrow are going for a holiday. We are sitting in an aeroplane. You are sitting in one place, I am sitting in one place, okay? So both of us are at rest with respect to each other. But to a bird flying outside in the sky, both of us are at motion. So the reference frame plays a very important role. The reference frame or the reference point. And definitely time also plays a big role in describing motion. So because this chapter is motion, you have to understand these two concepts now. So the reference point of frame from which we can understand whether the object is moving. An object means a body. A body need not be a living body. A stone is also a body for me, okay? So it's either called a body or an object. Clear? Okay. I'm just going to the whiteboard. I'll go to the first kind of physical quantity, which is distance. Your school is here, your house is here, home is here. Say your home is at point A. You take a school bus, okay? The school bus picks up 25 children and this is point B, your school. So the total distance which you travel, this is a road. So the school bus goes on the road, right? So the total distance traveled is the actual path covered. So the bus goes along this road and it covers the actual distance covered is the total distance covered. How will you measure the distance from point A to B? So usually you put a string or a rope and turn it along the curved path and then you can measure the distance. The second important part, so distance, what is the SI unit of distance? The SI unit of distance is meter. What is the CGS unit of distance? It is centimeter. Okay. And also sometimes foot is used. If you have bigger distances, suppose I live in, somewhere in Delhi and you are in Bombay. So if I go to tell meters, it will be a big number. So for measuring long distances, typically we use units like kilometer. We also use units of miles. So I say that, I am 500 miles away from you. So kilometer and miles are used to measure longer distances. And if I want to measure a small distance, I tell you the size of my nail. So I will measure in terms of millimeter. So small distance will be millimeter and longer distances, kilometer and miles. No. Okay. Yeah, I saw a question. So the Abdul wrote a question is, how many miles is a kilometer, right? So 1 mile is equal to 1 point, this is the exact 1 kilometers. So 1 mile is 1.60934 kilometers. In India, we normally use to measure long distances in kilometers only. Miles are typically used in US and Europe. Abroad. In India, we normally say by kilometers. Okay. Done? Okay. Now, I'm just rubbing this. I need this place. Now, suppose I tell you, let's calculate the shortest distance. I'm joining A and B with a straight line. So, which means this straight line is the shortest distance between A and B. And this is known as displacement. So I can write that displacement is the shortest distance between 2 points. And displacement is a vector quantity. The SI unit of displacement is the same as distance. It is meter. Understood? So these are very important concepts. As I told you, you need this all your life, as long as you study science. Done? Okay. So, Trisha, should I wait? Done? Because I can see you writing. That's the reason I stopped for you. Okay, right. So, can I also, I'm done. Okay, can I also write very safely that displacement is always equal to or less than distance. It can never be greater than distance. Okay. Now, suppose there is a circular football ground. You are standing here. This is you at the point A. You start cycling or walking, whatever. And you come back to the point A. So what will be the total distance? Let's say this is the center. This is the radius of the circular park. So the total distance covered by you will be 2 pi r circumference. Very good. Where pi is equal to 22 by 7. Right? What will be the displacement of you? So the displacement will be 0. So because you came back to the original position from where you started. Right? The same can be applied. Okay, this is case number 1. So displacement can be 0, but distance covered can be anything else. Suppose tomorrow again you come out for a morning walk. You start at the point A. After you're tired, you come to the point B and then you stop. So what is the distance here? So distance is half into 2 pi r, which is pi r. And what is the displacement here? So the displacement will be the straight line AB, which is actually the diameter of the circular football ground or football field or whatever. Clear? So we'll do a lot of numerical. This chapter has a lot of numerical questions. So we'll do a lot of numerical questions when you come back for the class. Today is just a demo. Okay. Understood, everybody? Pi is 22 by 7. It's a constant. Now, let's say I have a rectangular football field or a ground, a park or something. A, B, C, D. You start at A. You're walking like this. You stop at the point C. So what? Suppose this is the length and this is the breadth. So total distance will be how much? So total distance will be length L plus B. And what will be the displacement, not total? So what will be your displacement? So for displacement, you have to join this point A to C. So A to C, you can use Pythagoras theorem. I hope you know it, Pythagoras theorem. Know it, right? So you can use Pythagoras theorem and calculate the value of the displacement. Let's say you started from the point A, you're walking like this, and then you come back to the point A again. So total distance covered from A to A will be 2 into length plus B, which is nothing but the perimeter of the rectangle. And displacement will be 0. So displacement is always 0 when you come back to the position from where you started. So whether it is a rectangle or whether it's a triangle or whether it's a square doesn't really matter. You start walking here, you come back to A, displacement is 0. So the shape of the path does not matter. So displacement will always be 0 when you come back to the place from where you started. So your final position will be the same as the initial position. Okay, right? Done? Understood? Clear? So very, very important concept, difference between distance and displacement. So whatever I told you this, it's important to understand. So all of these are summed up. I don't like reading from slides. I will never read from slides. I don't like it. My funda is I will explain it to you and then I will show you what is given in the slide. This is there in all books. It is there in the study material also. You don't need to write, you don't need to copy, you just have to understand. Okay, one more thing. Did you notice this point? Displacement can be positive or negative depending upon the reference frame. So it can be negative also. Say that rectangular field, okay? A, B, C, D. I start from A and then I'm walking like this. And then again, I take another circle so it depends upon the reference frame from where you're starting. So if you cross the reference frame, it will be positive. If you end before the reference frame, it will be negative. I'll explain it to you in the class. We'll do numericals also from this, so don't worry. Important points to note are given in red. It's a scalar, it's a vector quantity, and displacement will be 0 if the body comes to its original position. And for both cases, distance and displacement, the SI unit is meter. So distance and displacement are always measured in meter, SI unit. Okay? Done? Okay. Now this is what I told you. A scalar quantity is a quantity which has only magnitude. The word magnitude in physics means numerical value. And a vector quantity has both magnitude and direction. So whatever quantities we will do, we will study first what is the quantity. For example, length, we have done distance. We have done displacement, like this, we'll do speed, velocity, acceleration, force, work, slots, gravitational force, energy, we'll do loads. So we'll study first what is it, how do you calculate it, what is scalar or vector, etc. Clear? This is also what I told you, the system of units. So FPS is foot pound second, CGS is centimeter gram second, and MKS is meter kilogram second. Done? All this is given in every book. You don't have to write also. This is very, very standard. Now, the next parameter that we will do is speed. So this speed is defined as the rate of change of distance. One very important thing, whenever you have rate of change of something now, this means that the denominator will be time. So the formula of speed, I know you know it, speed is equal to distance by time. And the SI unit of speed is meter per second. And speed is a scalar quantity. We sometimes also calculate, we will do numerical questions on average speed. So average speed is total distance by total time. Can you lower your whiteboard? I can't do anything to the whiteboard because the whiteboard is fixed. I'm using the whiteboard of Zoom. So neither can I lower it, nor can I zoom it, nor can I, make it higher. Everybody, can you see my whiteboard clearly? Can you see my whiteboard clearly? Just raise up your thumb if you can see it. Yeah. Tisha, are you using an iPad? Raise your finger, raise your hand. Nah, are you using an iPad? So the problem comes if you're using an iPad, then you have to change your, the position of the screen. I'm using the whiteboard of the Zoom platform only. So I can't do anything with this. This is fixed. I can change the position of the slide, but I can't change the position of the anyway, I'll write it lower from now. So I just told you the speed is the rate of change of distance. Okay. Speed is a scalar quantity and it's distance by time. Right? The next quantity, where I'll write it down for you, velocity. Trisha, is this okay now? Achha, velocity is the rate of change of displacement. So I told you, whenever there is rate of change, it means that the denominator is time. So velocity, displacement is a vector quantity, right? So therefore, velocity is a vector quantity and its SI unit is the same as speed, meter per second, but we normally also mention direction. Sometimes we need to calculate average velocity. So let initial velocity be equal to small u. This convention is used everywhere. Let final velocity be small v. So average velocity, average means mean. So u plus v by 2. And u as initial velocity and v as final velocity is used all across the world. So that is the good thing about science. Okay, the same alphabets are used for in all countries and everywhere. Trisha, is it visible now for you? Okay. Done? So that is exactly what is there in the, I can change the position of the slide. So speed is the rate of change of distance by time. Meter, acha, one more thing, meter per second is also written as this. So this is meter per second. So this is actually nothing but meter by second. So which is also written as this. It's the same thing. And average speed is total distance by total time. Velocity is the rate of change of displacement. It is a vector quantity, meter per second, and this is the average velocity is also, average velocity is also displacement by time. No, velocity is displacement by time. Average velocity will be always initial velocity plus final velocity by 2. Okay. Done? Next. The next parameter that we will do is acceleration. So as soon as your dad starts the car, he presses on the accelerator, right? So the accelerator basically increases the speed. So the rate of change of velocity is called acceleration. Let u be the initial velocity, v be the final velocity, t is the time. So therefore, acceleration A is equal to v minus u by t. This is a very, very important formula. So what is the unit of velocity? The unit of velocity is meter per second and time is also second. So the unit of acceleration is meter per second square, or ms to the power of minus 2. Acceleration is a vector quantity because it is the rate of change of velocity. Any questions? Not even one question till now, huh? Normally I have my classes are extremely, just prior to the demo, I had a class. My classes are very, very interactive. Loads of questions come. If you don't ask questions, I will ask questions. Okay. Done. Understood? Okay. Now, this is what I was telling you. So acceleration is the rate of change of velocity. It's a vector quantity. And acceleration is equal to v minus u by t. And the unit is meter per second square. Okay. Now, the concept of uniform motion. I will give you an example, okay? Suppose a train is going from, let's take from X to Y. In between there are stops, okay? So this is the entire path. First stop is A, second stop is B, and third stop is, say, C. Distance between X and A is, say, 5 meters, A and B 5 meters, B and C 5 meters, and this is also 5 meters. And say it takes 10 seconds, 10 seconds, 10 seconds, 10 seconds. So from X to A, 5 meters, it goes in 10 seconds and everything is the same. So this type of motion is called uniform motion. So what is that? So object travels in a straight line, number 1, and it covers equal distances in equal intervals of time. So this is what is called uniform motion. Okay, so the distances are the same and the time is also the same. Done. So this is what uniform motion is. So if you plot a graph, I hope all of you know graph. So this is the x-axis and this is the y-axis and this is the origin O. So we have distance in meters on the y-axis and the time in minutes in x-axis. So this is a graph. This line represents uniform motion. So which means what is the distance traveled here? So the same distance is 10 meters, 10 meters, 10 meters. 0 to 10, 10 to 20, 20 to 30. So in this case, the car or the bus is traveling 10 meters in 1 second each. So 1 to 2, 2 to 3. So this is a graph of uniform motion. There will be questions where you have to just look at the graph and you have to say what kind of motion it is. So by simply looking at the graph, you can predict or you can tell what is the kind of motion. Okay. So what is non-uniform motion? Please understand something. Non-uniform motion is, I'm writing here, unequal distances. The time interval will be equal in equal intervals of time. So this is a graph of non-uniform motion. So for non-uniform motion, distance will be unequal, but the time will be equal. Okay. Done. I will show you a few graphs. Okay. You will tell me what is happening there. Okay, it's written anyway. So this is a graph. So if you see on the y-axis, we have velocity, x-axis, we have times. This is a velocity time graph. So if you see that this is a straight line parallel to the x-axis. So this is x and this is y and this is the origin. So this is a graph of constant velocity. Velocity is fixed. So if the velocity is constant, what will be the acceleration? So acceleration is v minus u by t. So the velocity is fixed. So which means that the acceleration will be 0. U and v are same. Okay. So by looking at the graph, you should be able to say, now let me show you kaida karke. Can you see this graph? What is this graph? Type in the chat window. I'll give you 2 minutes. Tell me. What is this graph? Uniform acceleration, that's correct. So this is a velocity time graph with uniform acceleration is also correct, or with constant acceleration. Yes, absolutely correct. Abdul Sai Tapasya, yes, correct. So by looking at the graph, you should be able to tell what kind of motion is being done. And non-uniform or increasing acceleration will be like this. So this is a curve of increasing acceleration. In the Sai Tapasya, Trisha wrote, yeah, correct. Absolutely right. Okay. Now, I will tell you, in the class, we'll do it in details. So we will do the equations of motion. You have the derivations also. This will take, minimum, 2 or 3 classes, but now I'll tell it to you in short. So we have 3 equations of motion. V is equal to U plus AT. We have the derivations also in the syllabus. We'll do it in the live classes. S is equal to UT plus half AT square. And V square is equal to U square plus 2AS. Where U is the initial velocity, V is the final velocity, A is the acceleration, T is the time, S is the displacement. I think I've covered everything, right? So we will be doing the derivations of this also in the live classes. It's not possible to cover all of this in the 45 minutes that I've got, right? But in the class, we will do all of this. And the best part, as I told you, of this part of physics is that these equations of motion are universal. So they are the same wherever you go in the world. Just for this demo class, I wanted to do a few numericals. See, the entire part of physics, for chemistry also it's numericals for you. So I will just do a few numericals to just show you a few samples, okay? As to what do we do in the class. 1 second. See, the first question. A bus starting from rest moves with a uniform acceleration of 0.1 meter per second square for 2 minutes. My way of doing the problem or explaining it to you is, whenever you get a numerical problem, write down whatever is given. The bus is starting from rest, right? Initial velocity will be 0. Acceleration is 0.1 meter per second square. Time is 2 minutes. You have to calculate this, convert this into seconds. Find out the speed acquired means you have to find out the final velocity v and the distance traveled. So which equation of motion you will use? So I'm going to the whiteboard. So this is given. I have to find out v and s. So the first equation of motion is v is equal to u plus at. So v is equal to 0 plus. So find out v, do the calculations and tell me what is v. Please don't use calculator. Till your class 12, you are not allowed to use calculator in whichever board you are in. So V will be 12 meter per second. Everybody, 12, 124, how? 12, right, Abdul? Yeah. Okay. Now for the second part of the question, you have to calculate S, right? So you can use either, I'm writing in black, you can use either the second equation, S is equal to ut plus half at square, or v square is equal to u square plus 2s. Any one you can use and calculate S. So 0 plus half into 0.1 into 120 square. Do with the calculations yourself and tell me the answer. How did you get 6, Mayank? Everybody do this. So I have 0.1 multiplied by 120 multiplied by 60, right? So did you get 7200 meter per second square? Everybody got it? How did you get 12, Mayank? And if you do it from here, S is equal to V square minus U square by 2A. V we got as 12 square minus 0 square by 2 into 0.1. So that is 12 into 12 is 144 divided by 2 divided by 0.1. So no, this is 720, I believe. I made a mistake in the 0. So this is also not meter per second, meter SI. It is, both of them is 720 meters. Got it? So whether you do it using the second equation of motion or the third equation of motion, the answer will come the same. So we have loads of numericals in this chapter. We do huge number of problems. So I hope any questions, any doubts, we have 1 last minute left. So anything you want to tell, ask, anything? Nothing. No, nobody has any question. No, how was the class? Understood. Felt sleepy. How was the class? Type your comments in the chat window. Let me see. Boring, sleepy, went off to sleep, started dreaming. Okay. So before we wind up with this class, we have loads of numericals, but then this short period of time is not enough. So thank you. Yeah, it's okay, Tapasya. So thank you so much, all of you, for coming in this demo. And I hope to see you all in the live classes. Okay, and those classes will be interactive. I will not let you sit down so quietly. If you don't ask questions, I will. Right? So thank you so much, everybody. Thank you.